Hello everyone, my name is Nitin Gupta and I am here to represent my capstone project 2. It is basically an exploratory data analysis project on FedEx logistics supply systems. So this project type is exploratory data analysis and it is contributed individually by me only. And this is the GitHub link. The project summary is this is based on SCMS delivery history dataset, that is supply chain management system delivery history dataset. And its key area of focus are the primary objective of the of this EDA is to perform in-depth analysis on the supply chain management system dataset and to uncover patterns, identify key performance indicators (KPIs), and determine the primary cost of efficiency within the supply chain for health commodities. This insight gained from this project will be useful for optimizing procurement, logistic, and delivery performance. Data overview and scope. The dataset contains 10,324 individual delivery records with 33 features, providing a detailed snapshot of procurement and delivery process from the vendor to the client country. Now, problem statement. To analyze the history shipment data to identify factors, team, mode, country, Incoterms that drive on-time delivery and insurance cost to recommend actionable insights, improvements. Business context. The FedEx Logistics maintain a complex global supply, dealing with shipment across various regions, countries, and industries. The datasets provide an in-depth look at the logistic process, capturing the important information on purchase order, POs, and shipment methods, vendor agreements, Incoterms, and delivery schedules, and product-specific details such as description, dosage forms. Effective management of this process ensures timely delivery, minimizes freight cost, and improve customer satisfaction. The general guidelines. Now let's move into our uh, processes. We will firstly know the data. We will import necessary libraries, that is pandas, numpy, and for analysis purpose and for visualization purpose we use matplotlib, pyplot, and seaborn for non-interactive visualization and plotly express for for interactive visualization. Now we will load the dataset through our Google Drive and then we display it using df.head method. Then we will perform dataset first view using df.head. Then we check row and column count using df.shape. That is, it contains 324 rows and 33 columns. Now we will check dataset information using df.info. Then we will check for dataset description using df.describe. Then we check for duplicate value and then we check missing value. Then we apply necessary cleanup. In the cleanup, we will firstly load the dataset Then then the second process is data formatting. That that means we will format the date and time. Then in third process with numeric conversion and cleaning in data cleaning. Numeric conversion is basically we will convert the necessary numericals. Now, now our data is clean. Now we will move on to understanding the variables. So we will check for unique values. Then we will check for how. Then we will apply df dot column to find the necessary columns details. Then we will apply df dot describe include all, which for which we will see the necessary details. Then we will apply variable description. And this is the description of variables which are found in the table in the data set. Now we will apply the necessary data wrangling. In this, we will check for numerical conversion and as well as different types of. We will check for duplicates at the end so that we null values and duplicates, and then we will remove this duplicates and NA values, not allowed values. Now, what we will find from these manipulations which we have done in data wrangling. For date conversion, scheduled delivery date and delivery to client date, delivery recorded date was successfully converted to date time objects. For numerical cleaning and conversion, weighed kilograms and fried cost, that is in US dollars, columns which contain various non-numerical placeholder were cleaned, converted to numerical float data types, which is crucial for quantitative analysis involving cost and weight matrices. Then we will perform feature engineering and then we will missing value imputation, which is one of the necessary things because these missing values are further problem that can cause. Now insights for our next step. The data set has been thoroughly prepared, making it ready for detailed statistical analysis. And now the newly engineered delivery delay days, delivery years features can be utilized to analyze delivery efficiency trends and identify factor contributing to delays. This is our project hypothesis. Transport method bottleneck. Shipment via ocean will be the largest average delivery delay compared to air or truck freight due to longer transit time, higher exposure to port congestion, and increased custom variability. Geographical risk. Specific countries or regions will exhibit a significant higher average delay than the overall average. Now we will visualize the data. So we will firstly set up the data. Then we will first, our first visualization is a non-interactive line plot. That is item value trend over delivery year. So from this graph we can see that the mm, higher highest average item value is at 2011 and the lowest is at 2006. Now our second graph we will pairwise relationship of key numerical variable using pair plot. Line item value, line item quantity and delivery lead time delays and delivery delays and freight cost. And this is a comparison. And now in next bar plot, we will find the top 10 countries by shipment count. So the largest country is Vietnam and the smallest country is Zimbabwe. This is our next graph is an histogram which shows the distribution of item value. And from this graph we can see that the highest value reaches nearly in 13. It is slightly greater than 12 and its frequency is near 360 and 370. Now our next graph is also in histogram for delivery lead time. And it is highest is less than 100 days and the frequency is above 400. Our next graph is box plot and it is loading.
Let me connect to my Google Drive.
And this is the box plot. And here we can see that the highest average value is for HRDT and the least average values for MRDT. And and our next plot is for value versus quantity, which is a scatter plot. And our next plot is for average freight gross, average freight cost versus shipment mode. That is a bar plot, and it is maximum for air charter. That is 30,000 and above, and least for truck because transiting through air is takes much more amount of fuel, so it must be highest. Then we have our heat correlational heat map for numerical variables, and we can see that long line atom quantity has highest correlation coefficient, and delivery delays we can see a diagonal matrix. Now we will move on to our interactive visualization. Shipment value by product group, and the insights from this are the most immediate insight and the business implications. Management should focus on the group for optimizing shipping costs, inventory management, and ensuring robust supply chain as it represents the highest transactional value. As we can see from this bar chart, and the second insight is low volume product group. Conversely, the shortest bar highlight product group with minimal shipment activities. The low volume groups must be candidate for discontinuation, specialized handling, or investigation to underwhy why their shipment frequency is low, and other necessary factors. Now moving on to our second bar chart, which is shipment count versus shipment mode. By air, by ocean, by air charter, and by truck. And the dominant mode in this is shipment by air. The business implication, the company's logistics strategy, resource, staff, contract infrastructure, and costs are heavily concentrated on this dominant mode. This mode should be primary focus for performance monitoring, risk analysis, and contract negotiation for bulk distance, model split and efficiency. The chart provides a picture of model split, the breakdown of total shipment volume across different transport methods. Least used model. This shortest one highlights that is the truck. This is the least used model. Any disruption like port strike, airline capacity shortage impacting the most frequent mode will have the severe impact on entire supply chain. Now our next bar chart is shipment count versus vendor incoterms. And from this we have EXW as highest bar. It is most dominant mode, most dominant shipment count by EXW and least by DDU, DAP and CIF. International commercial terms. The dominant Incoterms and cost responsibility. The most significant Inco most significantly insight came from identifying toddlers bar which represent the most frequently used Incoterms. Understanding the term, the specific dominant terms, that is FOB, EXW, CIF, tells we are where the majority of legal responsibility, cost and risk, damage or life transfer from vendor to our company. If dominant term in C term, like CFR or CIF, the vendors cover freight cost, allowing the company more predictable shipment. If dominant is FOB or FCA or EXW, the company will be responsible for most of the major cost and risk, meaning logistic and cost control are highly dependent on our internal team and carrier contract. As we can see, EXW is highest. Highest use of EXWX workers. That is minimum risk and complexity for majority of shipment. Handling everything from address, loading, dock, onward. This gives major control but requires a robust logistic team. High use of DDP, delivery duty paid, indicates the vendor bears the maximum risk and cost. This simplifies logistics for your company, for our company, but often comes with higher unit purchase price from the vendor. Now our next graph is the delivery lead time. That is histogram we have previously plotted, but it is now in an interactive manner. So from this graph, the major insights are the most important insight is most frequent occurring lead time. That is this 60 to 79 days. And the peak of distribution represent the most common delivery duration. That is complete standard lead time. Variation in consistency is trade. The overall shape and width of histogram reveal the consistency of delivery process, our delivery process. Narrow distribution, if the histogram is still on narrow, it means lead time are highly consistent and cluttered, tightly around the mean. This suggests a highly optimized and predictable supply chain as we can see. And wide and flat distribution, high variability in lead times and inconsistent performance. Outliers and expanded delay shipment. Left and far right. That is this side and this side are extremely insightful. Left tells this tail. Bar far to the left represent very fast or expedited shipment. Might be exceptions handled by premium costly service. Right tail. Long lead time. Bar far to the right represent delay shipment. This require immediate investigation. This and bimodal the two peaks. Two distinct tall peaks. Uh, it suggests two separate consistent delivery process. It might be due to difference between domestic versus international shipment, or air freight or sea freight, having its typical lead time. Now our next plot is a box plot, which is delivery lead time versus shipment mode. And the necessary insight I have listed. Next is a scatter plot. Next is bar chart for average line item and managing office. And lead time versus shipment mode scatter plot. And the last but not the least, delivery delay versus line item value by managing office. And it is a scatter plot. Now we will perform the feature engineering, that is we handle missing values and outliers using IQR method. That is interquartile range detection and capping. And the solution for the business objective from this is the business objective for FedEx logistic performance analysis as outlined in the next notebook focus on optimizing efficiency. That is, we are optimizing efficiency, reducing cost, enhancing customer satisfaction, and improving overall operational effectiveness. This involves the key areas, that is cost reduction, identifying opportunities to minimize operational cost through route optimization, utilization, and streamlined warehousing. Efficiency improvement using streamlining process to reduce delivery time, improving sorting accuracy, and increasing the speed of goods method by analyzing bottlenecks. Im- Implementing automation and optimizing capacity. Customer satisfaction. That is, we are done using ensuring timely and accurate deliveries, minimizing damage, and providing transport track information to the builder customer loyalty. To build the customer loyalty. Now we will focus on quality enhancement, improving the reliability of service offering, such as on-time delivery rate, error rate, and responsiveness to customer inquiries. Risk management, identifying and mitigating supply chain disruption like weather delays, traffic congestion, or equipment failure through proactive planning. Sustainability, optimizing logistics to reduce environmental impact such as lowering carbon emission via route optimization and optimization, ensuring optimal utilization of assets like vehicles, warehouse, personnel to handle fluctuating demand effectively. In essence, the overall goal is to create a more agile, reliable, and cost-effective logistic network that adapt to market demand and consistently exceed customer expectation. And this is